Hi, this is Harish here. Welcome to DB2 tutorial part 2. In this tutorial, I'm going to talk about what and where are table spaces. The scripts, the data files that I'm using are available for free download at db2lewacademy.blogspot.com. Please subscribe to my YouTube channel, youtube.com/db2lewacademy. So this is the slide that talks about what and where are table spaces. Table spaces are both a logical way and a physical way. You can look at it both. Physically, if you look at, that's the most simple explanation that I can give, is you can understand table spaces as locations in hard disk to place your tables. So basically you're going to create table and put it inside the database. The table is going to reside in a table space, and that table space is nothing but a location in a hard disk. So this is the way we can understand in easy way. There are multiple ways to look at it. As I said, there is a logical component and there is a physical component. Physically, this is what it means. You can have multiple tables in a table space, and when I say locations, it in a hard disk, basically it means it will be physically a bunch of files or folders. And again, when I use a bunch of files or folders, which means I mean like multiple files or folders. So if one table space is going to use multiple files or multiple folders, they are called as containers. So each physical file which is part of that table space will be one container. So you can create a table space with two folders, which means two containers. If you are creating a table space with two files as the physical location, then it will be also two containers. So it can be either file based or folder based. So simply, so when you call it as a folder based locations, when you are creating table space based on like the folder based idea, then it is, we can call it as SMS, which is like system managed space. Even though there is a much deeper meaning for that, why they are calling system managed space, but we can simply understand this is for beginner level. We can understand physically, okay, like what is conceptual, what is under the back, behind the hoods, like what is happening. If you look at that level of difference, it becomes that level of detail, it becomes a little bit complicated. But we can simply understand that the folder based locations, if physically, if the SMS table space you want to locate it, it will be like a folder based location, and the DMS, which is the database managed space, will be file based locations. And each table in the system managed space will be mapped to a particular file. So it can map to one or two files based on like the number of containers, but it will map to a file. And if you have multiple tables, right, so table A, table B, table C, so each of them will have its own file inside the folder that the SMS is created. Whereas in DMS, it is completely file based. So each table, so if there are multiple tables, right, so you really can't say like, because the DMS table space itself will be only two files. Let's say it's two file based locations. There are two files representing the DMS table space physically in the hard disk. So if that is the case, then even if you create multiple tables inside that table space, they will reside still in the two files, but you cannot locate like saying this file is belong to table A, this file is belonging to table B, or this file belong to table C. So that's why each table is called as a set of pages or extents. So the DMS operates based on the extents. It's not like SMS doesn't have the extent concept. It still has, but it has the ability to differentiate between the multiple tables as files, whereas the DMS doesn't have that ability. So you can only just go to two the file based concept, and within that file where the table starts, where the table ends, again the records will be coming up, because you are not going to insert records and just leave it, right? There will be insert on table A, there will be updates on table A, there will be updates on table B, there will be creation of table C, there will be updates on table C. Everything in a OLTP database, it's all like there is no sequence, so random manner it's going to happen. So each set of pages for a particular table is called as extent, and you have to specify the extent size. And the pages, when I mean, it comes the table space, when you create, you have to create with some predefined pages. Okay, the predefined page sizes are 4K, 8K, 16K, and 32K. That is the most basic unit of reservation, or like a in at the hard disk level you are blocking 4K page at a file system level, or we can say like that, or a hard disk level like that, we can say, just for our understanding. It's not exact, I'm saying. Okay, And SMS, here are certain differences between SMS table spaces and DMS table spaces. There is a lot of container management that you cannot do with SMS table spaces. Like you cannot add or drop containers. At least it's not possible after creation, and there's no concept of high water mark. And storing user data is deprecated, which is very important. So just don't. So it's kind of, this is for just beginners and understanding what is an SMS table space. So you're not going to store user data in that. And the tables in the SMS table space will grow one page at a time, but overall the space grows one extent at a time. So that might be a little bit conflicting, but you'll have to see the demonstration what I mean by that. Okay, so the tables will grow one page at a time. The pages, the records, as you add records, one page at a time is getting filled, and there is no high water mark. And what will happen is, if you have in the SMS table space two containers, so 32 pages, let's say the extent size is 32, so 32 pages will be filled in one container, and for the same table, the next 32 pages will be in the second container, the next 32 pages will be in the first container, the next 32 pages will be in the second container. So it's going in a round robin fashion. So this, the table also grows, but it will block like one extent in one container, and it will fill page by page. And once that 32 pages or that extent size is over, it will reserve another extent in another container in a round robin fashion. So that is how SMS table spaces operate. Whereas when you come to DMS table spaces, you have full flexibility. So all the container management activities are allowed in DMS table spaces. You can add, drop, resize, reduce, extend. So many operations you can do. And since this is like a file-based approach, you have a concept of high watermark, which tells you how much the data is filled in that table space, or in that you are filling in terms of extents. So you never talk in terms of individual pages, but in terms of extents. So that's why there is a high watermark page up to which the table space is full, because it can be T1, T2, T3, like that. So you will have to, if you delete the records and all, like you will have to lower the high watermark like that. Whereas in SMS, if you delete the records, still that extent is blocked. Okay, so you just reorganize the table, you free up the space. Whereas um, in DMS table spaces, it's a little bit, it's still the same concept. You need to have the free extents, and once you have the free extents below the high water mark, you can reduce the high water mark or lower the high water mark. Again, there are multiple ways to do it. Why sometimes it will be successful, why sometimes it will not be successful, there are a lot of variations into that. We'll see that later, but just understand that there is a concept of high water mark. And tables grow one extent at a time, so that is for sure. Like there is no page concept here, it is one extent at a time. One extent of IO is turned into the one container for DMS, and the next extent will be into the another container. It can be of two different tables as well. So that's why there is a concept called as table space map. Whereas in SMS they usually don't talk about a table space map, whereas in DMS there is a table space map. Okay, we'll see everything in detail. So first we'll look at the SMS tables, like how the SMS is behaving like that. So here I have a virtual machine. So oops, something happened. Okay. Okay, so I have already connected to sample database. So let me just check DB2 list tables. Okay, there are no tables here. Okay, I'm connected to the sample database. So I'm going to create a SMS table space. So let's go here. So this is the syntax for the creation of SMS table space. So I'm going to copy that, and I'm going to the virtual machine, and I'm going to paste that. Okay, so now the SMS table space got created. So I should see data 1. So you can see there is one data 1, and there is a folder data 2. So two folders have been created because it is a SMS table type, SMS type. Okay, and once I create the SMS, let's look at the list table spaces show detail command. So let's see if I'm able to get that in the history. Okay, there it is, list table spaces show detail. So you can see the SMS1 Two pages are allocated and number of containers is also 2, which means one page per container. So we can assume like that. But um, but I really don't see anything here as such, because we did not create any table or anything like that. So um, we'll just assume that it's 2 pages to begin with. Okay, and just we'll create a table. So that's the next step eventually. So create table for KB. Okay, and we'll come back here and we'll paste create the table. So just because we created the table, look what happens for the pages 2. So it became 3 pages. So once it becomes 3 pages, and you can see the extent size is 32, which means 32 pages will be one extent. And you can see in data 1, so I can see this SQL002.dat, and you can see the file size also here, which is like ls-lh. So that should tell me 4K, right? And so this is really what is happening. So when you create a table in one container, it's creating the dat file SQL002, and that is 4K. And if I insert one record into that, right? So for example, I'll try to insert one record into that. So for that, I'll have to go and open a file 4kb.sql. Okay, so this is the insert statement that I'll copy. Okay, shift end, shift like that. Okay, that's the insert statement. Copy that, and okay, I have copied the insert statement, and I will go here. I'll say DB2 plus V hyphen T double quotes, and within that double quotes the insert statement is going to be there. Okay, it's about 4000 characters in length, and it's going to take a really long time. Okay, hit enter. So that SQL got completed. So you now from 3 pages it became 4. So if you look at the earlier output, I mean it was 3 pages, right? The total pages was 3. So after I inserted, it has become 4. So one page I have inserted, and you can see that one page is increasing the file SQL002 dot to 8K. So if I repeat this, so this is what I mean when I say the page or the table is growing one page at a time. So you can see that it became 12K, and if I run it one more time, it becomes 16K, and if I run one more time, it becomes 20K. So you can see that it is increasing, and see all these increases happening in data 1, and in data 2 nothing is happening, right? So this is what I was telling. So I have to exhaust the 32 pages. So if I exhaust 32 pages like this, so I will run that. Okay, so once, twice, thrice, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So that's some reasonable amount of data we have inserted. So you can see it has reached 128K, but that's not alone the surprising thing. You can see it has allocated SQL002.dat also, and that size is also it has increased. So what is happening here is so you can see this is 128K, and cd dot forward slash data 2. Okay, so that will be ls-lh. So that is 128K. So once I have reached the 32 pages of limit, what is happening is it is creating the same file SQL002 dot in the second container, because it has completed one extent of data in the first container in SMS Tablespace. So it is going and booking the second extent in the second container, which is data 2, and that file name is also the same SQL002.dat, which is similar to what is there in data 1, right? So it's kind of that single table is in 2 directory locations with the same file name because of the multiple containers, and each of them will be one extent in size, and it will grow. So for example, if I add another 32 pages here, right? So okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let me stop there and look at this, and this is still 128k data 1, and sorry, this is data 2, and in data 1, if you look at, it is still 131k, and in data 2 it is still 131k, so it has not increased. Okay, so it's now filling the SQL 2.dat in data 2, and once that 32 pages is complete, the data 1 container, this file, okay, this file should increment by another 128k, and it should become 256k. That is what we are trying here. So let me try another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so data 1, let's look at that. So it's still 130. Okay, and you can look at the data 1 file. So data 2 is still 128k, and you can go to data 1 and look for ls-lh. It's still 128k. So let me just do one more and two more. Okay, so let's see whether it has increased here. No. And let's go and do two more. So I think it's now 32 pages. I think it's close. Okay, it's still not there yet. Okay, two more. Okay, 32 pages. We are going to closely watch this. Okay, data 1 is still not coming. Okay, two more pages. As I add data, it should come. Okay, hold on. Okay, there you go. So once you insert, you can check it. Okay, I'm just running insert one by one, but you can check it. I have inserted roughly about 32 pages of data, and so from 128 it became 256, which is an increment by 128k. So if it is incrementing by 128k, each page size is 4k, that means exactly 32 pages. So it is incrementing by 32 pages, which is our extent size. So this file is now 32 to like 256k, and the data 2, right, like if you look at data 2, that will be in 128k. So if I look at that one, right, you can see that is at 128k. So now the data 1 container will get filled because it has allocated that 128k, right? So it has to get filled. Once this is filled, this will also become 256. So it kind of goes in a round robin fashion across containers, but it fills one extent of data in one container and another extent of data in another container, and it is pushing one pages like at a time. So it grows by the table is growing one page at a time, which we saw earlier also. And this, once that extent size is reached, it is pushing I'm not sure whether we can say it's pushing one extent at a time, but it is filling the extent, and it's before it switches the container. So basically you need both the containers data 1 and data 2 to recover this, because this file sql002.dat maps to the file 4kb, and that is in present in both the folders, and one extent will be in data 1, one extent will be in data 2, the next extent will be in data 1, the next extent will be in data 2, in a round robin fashion, and that is how it is distributed. So this happens on that particular table, and if I even delete some records, right? So for example, if I say DB2 DELETE delete from 4kb FOU or kb, delete from 4kb, where, okay, let's look at that example here. So delete from where, okay, like delete from 4kb, I'll just copy that. Right click, copy, minimize, and go back here, and I'll just say paste that. Oops, it did not paste it properly. I don't think so I copied it properly. So let me just go back and go to the text editor, right click, copy. Okay, I did that. I'll go back here and I'll say paste. Okay, now it's pasted. So I'll say anything beginning with 2. Okay, 2 0 or maybe. Okay, so delete, and I'm going to select the record. So DB2 SELECT select count of star from 4 KB. Okay, so that's the records count. So I have deleted the records. Oh, so all the records got deleted. Okay, so which means I have cleared the table basically. So if that is the case, if I do list table spaces show detail, it's still 98 pages, right? So if it is 98 pages, what that means is this file is 128K, and in data 1, it is still 256K. So even though there are no records and I have deleted it, that file size is not reducing, right? So that is still 98 pages. So that is the time you have to say rearg table name 4KB, and that should lower like your space capacity, right? Because see, it became 3 because there are no records at all. So like if you look at the data 2, that file is still there but 0 bytes, and in data 1 you can see that file is still there with, oops, I don't know, it's showing like that. It should be 0 bytes, right? So in data 1, okay, there is just a simple 4K. That's maybe because of the definition or something, or because of the rearg or something. So that's still up there, okay. And in data 2, so let's go to data 2 and ls-lh. So that became 0, okay. And I have deleted all the records, and the table is also gone. Oh, the table object is there, right? So the table object will have to take some space. So we cannot remove that. It cannot be, this cannot be 0 unless I drop the table, right? Because that table object is still there. So I can even do that. So if I say DB2 drop table, so the point is, if you rearg that file size has reduced drastically as per the number of records you are deleting, and the corresponding extents are removed, which is shrinking the file size of the SQL00.dat. And if you drop the entire table, FOURKB, if you drop that entire table, and you should see that entire file becoming 0. Like, see the 2.dat and 2.dtr. DTR is the rearg record or something. And if you go to data 2 and run the same command again, you should see 0. So basically that 02.dat is gone. But I can use it to create. So if I say, for example, I can use the same statement and just create a table with a different definition, obviously. So I'll go to like here I'll create KB4, like, it's just a wordplay. Okay, so copy that. Oops, this is what is happening. So copy that and come back here and right click, paste it. So no, it did not copy. I don't know why that happens. Okay, right click, copy, minimize, and okay, now paste it back. Okay, see, now I have created the KB4, and you should see in data 2 it's the same, but you go to data 1, there you go, it's using that 4KB. So how do I say that is, if I do an insert right into KB4, the size is going to increase accordingly. Okay, so see, now it is 4K. So if I go and insert into KB4, right, so then I need to copy that command, insert into KB4. So that SQL also I have, so you can try that. Okay, so this is an insert command. So shift end, control C. Okay, close it, minimize, and go back, and DB2 plus V hyphen T, and double quotes. So within the double quotes, I'm going to paste that. So insert into KB4 is what I have done, and I don't need the semicolon. Okay, so there you go. So the insert is successful. So for KB it becomes 8, and if I do it one more time, it should become 12. So if I do it one more time, it should become 16. So this is how the SMS tables work, and so this will go up to 32K. So once it reaches 32K, it will reuse the second data file. So because page size is 32K, right? 32 pages, sorry. So 32 pages is like it's really huge. 32 pages is like 128K. So I am at only like 28K. So if I have to make use of the other container, I have to breach that 128K mark, which is 32 pages. Okay. So this way you can drop the table and make it the DAT file as 0, and once the DAT file becomes 0, it can be reused by another table creation. And you can see the 4KB it has created for SQL002.dat in both the containers now. Okay, and another aspect of this SMS table space is if you are going to create tables like this, right, further tables, it will go in a round robin fashion. Like I'll copy this create table command and I'm going to run it here. Okay, hopefully, yep. So if I run this KB4, right, so where it is creating that file, see, it's not in data 1 but it's in data 2. See, this SQL003 is that particular table creation. And if I go again do this table creation with KB5, so see, it was in data 2 as 03, right? So this will be in data 1. So you can see here in data 1 it's creating that 045, and the next file will be SQL005 in data 2. So I'll do like KB6. So every table is put in one container in a round robin fashion. So data 2 should have the 5, the number 5, and data 1 should have the number 6, which maps to this file, this table. Okay, so data 1 should have 6 exactly. So the table creation is going in a round robin fashion across containers, and they will fill up, and once it crosses that extent size, it will use the data 2 also. Like it's not like the SQL6.dat is, because it is 4KB, it will go up to 128KB, which is 32 pages, which is the extent size. Once it breaches that extent size, it will, the same SQL6.dat will be created in the second container, which is data 2. And there is no concept of high water mark, and you just delete the records, the file size remains the same, and you rearg the table, that particular file, whatever that table it belongs to, you just rearg, all the pages will be reclaimed and it will become 0. So it's all done at the OS level, and you cannot add containers, you cannot modify containers. So this is the most simple way to understand how this works. Like this is how the SMS table spaces works. We'll see how DMS works in the next video tutorial. Hope this information was useful to you. Subscribe to my channel DB2 LUW Academy. See you in the next video tutorial. Until then, bye bye.